This video segment will go over the gradient calculations as presented in the content. We're going to do linear growth, or arithmetic as it's termed, and we'll also come down and do the geometric. We're going to start with the annual payment being $6,000. We're going to do this in starting period 1. And the annual increase every year is $500 larger. $6,000 the first year, the second year is $6,500, then it grows to $7,000 to $7,500 and so forth for 10 years. The easiest way by far is a tabulation. There are equations we'll look at very shortly in a minute, but we're at least for the geometric. So let's just take out some of this so you can illustrate better what's going on. 6,000 beginning in the period 1. Deposit at the end of the period is 6,000. So the deposit at the end of year 2 would be that cell, B8, plus the annual increase, which is in C3. But we want that to stay the same, that increase every year. So let's go put dollar signs in front of it. That way we can drag it down and it will not change. The B9 changed from here, the C3 did not. The interest, there's no interest in year 1 since it didn't get deposited till the end of year 1. So we can do the interest, which is equal times the balance times the rate, which is 5%, the annual rate. And again, we want to keep that constant, so we'll put dollar signs in front of the C and the 4. The interest the first year is 3,000. So the balance at the end of that first year 2 is equal to the balance at the end of year 1. Plus, note that I'm just positioning on the cells, and that fills it for me up above. That's the deposit, and here's the interest in C9. So at the end of year 1, we will have 12,800. That's 6,000 plus 6,500 plus 300. And then the rest of the cells, we can just drag down. And there is our result. In 10 years, we should have $101,246. That's the linear situation. The geometric increases by an annual percentage each year. For instance, if we have 6,000 in into year 1, 3% increase would be added $180 of that, so it becomes 6,180. And that's the only thing that changes from the above. The interest and the balance stay the same. So this equation is B26, that's this one right here, the original 6,000, 1 plus the rate, 1 plus the 5%, the rate's in C21. And if you have that, you can just drag it down and obviously get the same values. And that results in a $85,493.47 balance at the end of year 10. A little bit less than this. This is growing faster. The 500 is faster than that. Arithmetic wouldn't necessarily be if we change this to 400. See, it's down to 96, getting closer, so it's equivalent to, say, about 350. 93, 85, even less than that. But you can play with this as you want. And that's the beauty of spreadsheets. And that's your two types. It's not limited to 10 years, obviously, or rates or anything. It's just a standard tabulation. There are equations, both arithmetic and geometric, for this. Same values, 6,000, 3% growth rate, interest rate is 5%, 10 years. And this is the equation. You'll see C38 is A. You could fill in the others and it comes out 85,493, which turns out to be the same as this. It will work. If you want the present value of these 10 years, there's another equation for that. and it's 52,485.58. Again, there are ones for arithmetic. They're even more complex. If you have a lot of free time in your hands and nothing to do, maybe you want to play with these. Otherwise, if you're like most, stick with the tabulations. Thank you.